Pocket में? अच्छा, that one. Yeah. Okay, very good morning to everyone. Actually, we are late little bit, so sorry for that one. We went to that building, your Bomatra boat in that part, headquarter. So we got late. We are planning to come because address we did not properly, we could not communicate. So that we are very sorry for that one. So today, already you have got my introductions. Myself, Sankar Nath Dey, Officer Surveyor from Survey of India. So our today topic is on CORS. You have heard about CORS, I think so. If not, this is as like a GPS has been permanently set up. So first of all, we will introduce Survey of India to you because you may have heard about Survey of India. So about Survey of India, it was established by this one British East India Company in the year 1767. So the first, it is not Surveyor General. It is the first Surveyor General of Bengal. He was first Surveyor General of Bengal, James Randall. That time, what happens? No, part Maharashtra also there, Surveyor General Maharashtra and Surveyor General Chennai. Like this was there. So Bengal was first one that was created by British East India Company. So then it comes Major William Lambert. What he has done, he thought that we should measure the Indian territory. Why? Why they want to measure the territory? Because they are conquering some of the territories from the kings, different kings. So they want to know what is their territory, how much territory they have. So they want to measure the territory of India, whatever they have. So they have start mapping. They want to do the mapping. For this they have done triangulation. They want to do some, how they will do that one. So they have measured one baseline in Bangalore. That is not mentioned, just I am mentioning all the stories, little bit gist on that story. So in Bangalore, what they have measured in 1800s, they have start measuring one baseline. They have measured, that is 12 kilometer distance they have measured. How they have measured? They have used chain, steel chain, and there is a the property of steel chain is that while because of heat it will expand. So they have to keep it very nicely in the tent so that only at the time of using only they can bring it out and they will use it. So these are the properties. For that they have to measure temperature. They have to take the temperature also at that time period, how much it is expanding. These records they are keeping each and every time. So 1800 they have measured 12 kilometer distance, and it took almost 2 months, not 2 months. I think it was October 14, 1800 October 14, and they have ended it in 1800 December 10th. So less than 4 days, 4 days less. So it took 2 months to complete that distance. So what was the thought? Actually, they want to show that to the higher authority that if we measure only one length, then we can calculate other length. We can calculate distance, other distances. Because in triangle, what happens if you have a triangle? If you know the base and two angle, you can start calculating the other sides also using. I think you have heard about sine formula. A by sine theta, A by sine A equal to B by sine B. That formula you can use, because if you know the two angles, you can find out the third angle also. So you got A, B, C angles, and you know one side. So A you know, so you can find using other side also. So this way one triangle, adjacent triangle, this way it has gone. So what they have done, this is the weight line. So they have shown that this is a successful one. They need not to measure every time the length in the ground. They need not to measure the length every time in the ground. So they have measured this one for just showing their authority that this we can do. Later on, what they have done in 1802, they have done the great triangulation. This triangulation start from Chennai to Himalayas. It took so many years to complete that one, that process. They have to bring out the instrument theodolites to measure the angle. From London, they have brought those instruments, theodolites. Theodolites means these theodolites are very heavy. It needs 20 people to carry these theodolites. So they have done this triangulations. So William Lambton started this triangulation, great triangulation. Later on, you have heard about Everest. That Everest was measured by, height of the Everest was measured by George Everest. So actually calculation part was done by one Indian, but his name did not come up. It is Radhanath Sikdar, who has calculated the height of this one, Everest, Mount Everest. But being he was the in charge of that calculation team, so George Everest's name came up. The credit was not given to Radhanath Sikdar. So this is our legacy. Means we have measured the, we can say that we have measured the height of the Everest. So later on, we have a means these maps are created. These maps are, for creating maps we need printing. So British has prepared some printing machines and these things, and there we start printing maps. So when the Constitution of India was first we have to publish, when it was written, so it has to be published. So it was first printed in Survey of India press. Even postage stamp also printed in Survey. I am telling only the legacy of Survey of India, what we have done, so that you know about Survey of India. And I think you have seen our topo sheets also. Either whether you have seen our topo sheets. So this was done very, it was very tedious to do that one. That time no facility was there. They have to walk such a distance, and then only using chains and these things they have measured throughout India. So it is our legacy. We are getting data from them, and we are using that data. So postage stamp also printed in Survey of India. So these are the things. Later on, when this 1962 China war happens, so our survey government of India thought that we need to measure the Himalayan boundary. So this was also done in 19. So there that time we have start using photogrammetry process. Survey of India brought out photogrammetry process. In photogrammetry process, some helicopters are used. Some helicopters are used taking photographs. They are georeference, and that are done mechanically. Instruments were there, mechanically that were done. So photogrammetry also brought by that time only. So after that, now everything satellite geodesy come up. These are modern. Digital cartography we are doing now. Sea level rise studies, that is we are observing tidal observations. Every means data we are every day's data we are collecting, tidal observations, so that we can get the MSL heights. MSL for getting MSL heights. Tidal observation data are every 19 years. Means there is a certain published. After every 19 years we publish, we send the data. Okay, so these are the now our this time we got CORS. Now we are working with the CORS and GNSS era. This is the era where CORS comes into being. So we have established CORS throughout India, almost 1,000 CORS, more than 1,000 CORS we have established. Out of this, some CORS, it is mentioned here somewhere in this PPT. Out of these CORS in Assam, we have 35 CORS, CORS stations established. What is CORS? CORS are the permanent. This is some we have ports, one receiver there, and one antenna is also there. We will show you the figure of that CORS. So in Assam there are 35 CORS stations established. So they are giving data continuously. They are sending data to the central server. It is in Dehradun. So this CORS sends data to the central server. Before going to the CORS, we will tell you regarding MSRF. This is a national spatial reference frame evolutions, how it has come up. You should know this one. Previously this triangulation was done. So from triangulation what happens, some points were created in hilltops, and some construction also done, so that that point can be read. So we got some points through great triangulation. This was done using theodolites and this thing. This is one era. From there we come up with GCP. GCP you have seen. Have you ever seen Survey of India GCP? If you, this is in the era, in the time 2005 we have started providing GCP. That was used by GPS only. Normal GPS. That is only that time only GPS was there available. GPS means only American satellites. When we say GPS, this is only American satellites. There are 24 satellites which has been established by US defense organizations, and that GPS we have used to prepare these GCPs. So almost every 300 kilometer there was first phase GCPs we have created. After that we have brought down to 50 kilometer apart. So there is numbers are there. I will have to see it. Then we have come to new reference frame CORS, because previously those survey were done before 10 to 20, 15 years back. What we have done survey based on GCPs. So in ground we have prepared one open this one construction. We have a small construction we have created and observed there. 72-hour observation we have carried out using GPS instruments. GPS instruments, and the coordinate we have brought out. There are ITRF. Did you heard about ITRF? This is in International Terrestrial Reference Frame, because what they have done, international body is there. They want to. They have prepared some stations. India also is a part where they have put some stations. This is to synchronize with international levels. We are synchronized with international levels, so they have prepared international ITRF stations here. One station is there in Tezpur. I think another is Hyderabad. Hyderabad is also there. This way they have created ITRF. So to synchronize our GPS, these coordinates are synchronized with international standards. They are synchronized with ITRF standard. So it is mentioned, I think. We will not go through this one. So these GCPs were created. Later on we have converted to CORS. So we will go directly to the CORS. Why switch to CORS? Okay, there is, it is mentioned, CORS stations are actively reference points. They will replace older passive GCPs which need more maintenance. In CORS, because GCPs need maintenance, they are open and they get destroyed, because at present in Assam we have 70 GCPs. Out of that already 40 out of that 40 has already been destroyed. Whatever GCP we have created in the year 2005 to 2010, most of the GCPs has got destroyed, because they are already openly kept there, so they get destroyed. So to maintain that one is very tough. So now we have prepared some CORS stations. So this is CORS station is easy to maintain, more accurate and more reliable. The data provided by CORS are more reliable and more accurate, and can be used for precise survey across India. CORS station can also support network RTK. So okay, we should go this way. So now when we are going using GNSS, what is the GNSS? Global Navigation Satellite System. In GNSS, what you will see, previously it was GPS, no? Now it has come, the word has come up as GNSS. GNSS means constellation of satellites. America has 24 satellites, that is GPS. Another one is GLONASS. GLONASS is a Russian satellite constellation. They have also 24 satellites. Galileo is another constellation. It is of European constellation. Another is China has also sent satellites to like GPS. and that is Baidu. So these are the fours. And India also sends satellites, IRNS. So these are the satellites constellations, because GNSS is using all the constellations. These constellations are in GNSS survey. These constellations are used. So this what I was telling, this was the triangulation station created. This you can see in West Bengal one, in Calcutta one, this tower is there, and we are trying to protect this tower at present, because this is our legacy. So we are trying to protect this GTS tower, Great Triangulation Tower. While going through from this triangulation process, these towers were created, because in plain area that point will not be visible through satellite. To see through satellite, these points were created. And in hilltop, I think in Assam you will not get this type of stations. Why? Because in Assam you will get all the hilltops. So in hilltops they have put points. So that is not needed in Assam. But where there is plain, to see this from far distance, this concrete structures were created. So this is what I was telling, that GCP were created. In phase 1 we have created 260 GCPs using GPS. That is 20 kilometer apart. Another later on we have make it 2260 GCPs in phase 2. That is 30 kilometer apart, 30 to 50 kilometer apart. And this is the GCP station. See, you can see the GCP stations that we have created. We have done somewhere 72-hour observations. We have done 72-hour observation on that one. Then only we have got the coordinates of that one. So now we have established CORS, that we have mentioned that more than 1000 CORS are established throughout India. This is the CORS network, CORS network throughout India. CORS based update national reference frame. This establishment of CORS network throughout India coordinated in ITRF 2008 epoch, epoch 2005. Means actually one thing I want to tell you, that every time our arts, every year our arts, suppose our position is here, so every 1 year that we are moving 5 centimeter apart, means we are going 5 centimeter. Every year it is changing our positions because of this plate tectonics, distortions, many things is happening, natural calamities and these things. Every year 5 centimeter we are moving. Suppose our position is there, you can see the timeline of images in Google Map. You will, if you put timeline of images in Google Map, you will see that the images after 5 years will not sit in same positions. Means now it is, say, 2005. If you take this epoch is our coordinates, all the coordinates we are measuring in epoch 2005. The first base coordinate was taken as 2005, 5 coordinate. So we are calculating all the coordinate based on this epoch 2005. Means the base coordinate is of 2005. So when you see in Google Map now, you will see the images in 20 years. This is 25. And from 2005 to 2005 you take 20 years means 1 meter shift you will see, because every year it is moving 5 centimeter. So there will be a shift of almost 1 meter has happened. So whenever now your position is here, means previously it may be somewhere else, these portions. Okay, this is mentioned here that what is GPS. GPS is USA based satellite, and then GLONASS is Russian, Galileo is Europeans, and Baidu or Compass is China based, and Indian one is IRNS, and Japan also have sent satellites. So we are not using Japan one. So how CORS work? See, in finding out the coordinates, there are two processes of two way to get coordinates. One is static way, another is RTK methods. These are two methods. Static means you take the observation, Okay, it is not mentioned here, but just I am giving you the information regarding that one. Static means you take the observations in the go to the field, take observations for a certain duration, and you come to the office and do post processing, do the post processing part. In RTK you will get the real time coordinates, means real time kinematics, RTK. So CORS, while using CORS we are getting real time coordinates. So this is the RTK method we will be using. Mostly in CORS we are using RTK method, and this will give you almost centimeter, means 2 to 3 centimeters accuracy. The accuracy is 3 centimeter accuracy, um, even less than that one. Even less than that one you can get through RTK. So in RTK methods, what happens? This is the thing what happens, how this is calculated, how coordinate is calculated. I will go through this one. Actually we know that how we will find distance, rate into time. Distance is calculated by rate into time. So suppose satellite is there, one satellite is there. In that satellite there is a atomic clock, and it has a very good accuracy because of that. And this receiver, one rover is there. This rover I will show you. That rover has also one clock. There is a rover that will also have a clock. So that time when the this satellite is sending some informations to the rover, and so it sends the time also. That suppose T1 is the time sent by the satellites, and when it reaches to the rover, that time is T2. So here it is mentioned T2, TS is the satellite time. Here it is mentioned below. You can see this is TS and this is TR. These are the two times. So time difference we got, and we know that since this the satellites, those signals they are sending, no, these are electromagnetic resonance. Every electromagnetic resonance signals, the speed is as of lights, 3 into 10 to the power 8 meter per second, that is c, speed of light. So this if you multiply that one, we can get the distance, but this distance is a pseudo distance. It is called, why it is called pseudo distance? Because the that signals we are getting from GPS to rover, they are not some, you will get a troposphere, you will get ionosphere, you will get atmosphere. So because of ionosphere correction is there, some errors are there because of ionosphere. So there is a deviation in the path. So it is not coming straight forward. So there is a difference, difference in the distance will be there. So because of that, that is called pseudo distance. It is not the actual distance we are getting. We are getting the pseudo distance. Another thing is we need see, satellite has a coordinates. Satellite has its coordinates x, y, z. Its position is always changing. So this we got the satellite positions, and our position, suppose where it is, we have x, y, z positions where we are standing. So you know the formula that we can find out the distance, root over x1 minus x2 whole square plus y1 minus y2. So from this one also we can get the distance, and from that formula also we can get out the distance, that c into that t1 minus t2. So using these two things we have to calculate the coordinate of the unknown points. So to calculate the unknown points, we need 4 satellite at least, because there are four variables x, y, z. So at least we need 4 satellites to calculate the positions. So because there are 4 variables, so we need 4 satellites. At least 4 satellites is minimum requirement, is 4 satellites to calculate these x, y, z coordinates. See, whenever the satellite is sending signals, there are some distortions. These distortions are occurring because of ionosphere. In ionosphere there are charged particles, because ionosphere always contains charged particles. So because of these charged particles, there is a certain distortion. Even there will be reflection also, because of atmosphere. Atmosphere also, there will be a reflection. This refraction will be there. So this bending, the path is not straight. It is there. That's why it is called pseudo path. So these distortions we have to correct it to get the accurate coordinates. So to correct these distortions, some known coordinates has to be needed. Using those known coordinates only we are doing the corrections part. So this one, it is mentioned that, see, it is mentioned this satellite clock has a difference. This is the error, 2 meter error can be there, maximum 2 meter errors is there, because of orbit also, because the satellites are moving in the orbits, in geosynchronized orbits. Satellites are moving on geosynchronized orbit. You know there are 3 type of orbits is there. So satellites are present in 3 type of orbits. One is geo, one is LEO, one is MEO. MEO means middle earth orbits, LEO means lower earth orbit, and geo means geosynchronized orbit. Geosynchronized means those are parallel to the equator. Those orbits are parallel to the equator. And LEO means lower earth orbit. These are perpendicular to the equator. Means these are this perpendicular to the equator means these are these orbits are towards pole in this way. And another is middle earth orbit, that is inclined to the equator, 45 degree inclined to the equator, that geosynchronized orbit. So these are the there are chances of getting orbital errors. Ionospheric delay is also there, tropospheric delay is also there, receiver noise is also there. Multipath means because of buildings this will divert, this will get reflected. So where we are using this today's this IoT device are also connected with so many things to get information, and even in car also we are now using GPS for locations. Then in agriculture purpose also we are using GPS. So since GNSS accuracy is limited by various error sources including orbital errors, satellite clock errors, receiver noise and atmospheric delay resulting in precision dilutions, to overcome this limitation, various survey techniques are employed such as DGNS, static GGNS survey, RTK survey, satellite based augmentation system, ground based augmented system, precise point positions. Differential GNSS is this is another one process. We are using static as well as RTK. In Survey of India we are using these 2 methods only, the static GNSS survey and RTK method. Now this is not RTK, that is network RTK, because of the codes we are using. In differential GNSS what is to do, see suppose we have here we have to, in differential GNSS we have to use 2 GPS. One is known coordinates, another is do you have boards? I can show you in boards, it will be better. Can I use board? Yeah. It will be better to describe. Can I have the pen or this? See, in differential, suppose this is one GPS. We know the coordinate of these points. These points, it is known coordinates. This is known. This x, y, z is known of this point. Another GPS, this is unknown points. This is unknown. Okay. So what happens? This is known points, and this is unknown. There is a radio. This is transmitter. This is there is a transmitter. It has also a transmitter. This transmitter will send signals to this. And GPS observation is going on. This observation is going on. It has one coordinates. Because of GPS, some errors is there. So because of errors, suppose this is the position it has find out through GPS, and this position is known, and here it is the position, suppose. So this position is known, so there is a deviation in the position. Suppose this is 2 or 4 centimeters, suppose. This position we have got here. So through radio transmitter, it will send signals to this one. It will tell that your position, suppose this is the position, it will come up. It will tell that you have to bring your position to here, means shift your position to 4 centimeter to the left or right. So it will give signal to this one. So this corrections is sending through radio transmitter. This GPS will send signals to this, and it will ask them to shift your position to this. So we will get the known coordinates of this one also. The correction will send through radio transmitter, but there is a limitation. This cannot take place when 20 kilometers, maximum 20 kilometers, base to base. We can find it out, maximum. With better GPS instrument that we can find out 20 kilometers, we can find it out, the coordinate. So same thing. So here we need 2 GPS to reduce this work. Suppose we have gone, 2 people have gone to the field, we need 2 people, 2 teams is required. Here we need 2 teams to carry out this process. To carry out this process, we need 2 teams. Again, we have to take this instrument and we have to collect this instrument, then we have to go out. So this is it is time consuming process. So to bring out this time consuming process to easier way, so we have established 4 CORS. Suppose so we have CORS stations. These are permanent CORS stations. These are sending. Suppose these permanent CORS stations. Something. And one more thing we want to tell. One more thing I want to tell you, how these coordinates are calculated, means how precision is coming up, means why this precision is coming up. This GPS is observing how this one. Okay, let me go through codes. There is a CORS station established here. And there is a control system. So these are permanent CORS stations. Now this RTK method has gone into NRTK method. NRTK means all the constellations, 4 constellations, take it 4 constellations, will take 4 constellation into it. All the constellations satellite will be sending data to the receiver. Suppose our rover is there somewhere in between here. This is our rover. We are keeping our rover here. So rover is sending, and these are satellites. This is moving. we are sending, rover is getting signals from this satellite, and it is sending here, and this is continuously it is sending. It is getting from here, this is continuously sending informations. So these informations are sending to the coordinates. This informations, all the informations are sending to the control system, which is located in Dehradun. Our control system is located in Dehradun. Server is located in Dehradun. So this is also getting signals. Same satellite is sending signals to this one, to our unknown points. Suppose we have set here. So we are sending signals. So in RTK methods, there are three ways of calculating coordinates. One is VRS, FKP, and MAC, and another was there MAX, MAX, but we are not using. Mostly we are using VRS method, virtual reference station. We create one virtual reference station. So it what happens? It will create one virtual reference station near to that rover. This is virtual. This is this. So receiver, this control system will send correction of these virtual stations. This control system, because correction we are getting, because these CORS stations have already coordinates, permanent coordinates. These CORS systems, these stations have permanent coordinates that we have established. So they will get information from satellites, and they are sending to the control room, and these are coordinates. So difference of whatever difference is there, it is finding out in control system. Here also this CORS will send signals, and this way again whatever correction is there, these corrections are sent to these virtual points, regarding this virtual point, and these corrections will be same for this one also. So these are sent through internet. So we will get the coordinate of this portion also from control system. That will be shown how while doing practical, we will show you how the coordinates we are getting. So this is the technique we are getting those coordinates. So this is RTK method, is that one. First RTK has come up into course based RTK, that is NRTK. We are using NRTK. And this graph you can see regarding course BPC, this accuracy of the coordinates come with the duration. If you take longer duration of data, the accuracy will be more. So this graph shows, see 10 minutes, if your observation is for 10 minutes, the accuracy is almost millimeter accuracy, and when you are observing for 1 second observation, or this 1 second observation, here it will be 10 centimeter, 10 centimeter accuracy. So depends on the duration, how much time you take observation. This accuracy depends on time. So real time versus post processing. So real time, you are instantly getting the coordinate. What is the difference between post processing? Post processing, you take the observation in the field and you come to the office, and then you calculate through certain software is there. We are using TBC softwares. This is Trimble Business Center. We are using that one. And real time, you are getting the coordinate directly in your receiver. You can see the coordinates. So this is instantly you are getting the coordinates. Results are available in the field, so check can be verified immediately. Stakeout is now possible. What is stakeout? Suppose you know the coordinates. Suppose you know the position. This coordinate you know, but you don't know the position of that point. So you can use that GPS to find out. It will show you, go to the right, go to the this little bit 10 meter back. This way you can find out. Staking out means finding out the position of the points. Actually, why we are using, first of all, I have not mentioned this thing. Why we are using this GPS means why you are finding out these points. I think you have also used. Suppose actually I have gone certain meetings in your Brahmaputra board. You are surveying 15 river basin project, isn't it? In that one, you need some mapping. You are going to do mapping of 15 river basins. So for doing mapping, you need some control points, because that mapping will be carried out using drones. Drone will take photographs. These photographs are not georeference. These are only a photograph. So to georeference these photographs, we need control points. So using CORS, we can give control points. So using that control point, we will georeference those photographs to have a accurate picture of that land, accurate picture of the land. So georeference with the art. So that's why we are using. One CORS receiver support multiple rovers. So you can use so many rovers at a time. So at a time you can use so many rovers. No post processing time required in office. All the survey work done using CORS will be in common consistent national reference frame. That reference frame will be same, CORS based reference frame, because otherwise someone will observe in another reference frame. Suppose you are taking GCTs, you are not using CORS, you are using GCPs, whatever we have established earlier, you are using that GCPs. So there will be variation in the coordinates. You should be using, so to bring in same reference frame, we are Survey of India is trying to, means asking every department to use CORS. That's why we are here, so that you use CORS. All the data will be synchronized in same reference frame, CORS based reference frame. And why we are giving you the training, because whenever you do the survey, you kindly use CORS. So we are here to get you registration. All we want, all the data should be in same reference frame. There is no need of transformation to be done, because we are also creating one transformation. Survey of India is creating one transformation model that can be used but not yet created. But we want it, the national reference frame should be same. Whatever data you are creating, that should be in same reference frame. All the survey work done using CORS will be in the common consistent national reference frame. Further, the service could be integrated with various GIS applications. Through GIS application also, at present we are doing Naksha project. In Naksha project, what we are using, web based, we have given this one in Dimapur. Suppose we have done survey, means drone survey we have done there. So these drone images are put up in web based server. These images are put up in server, and the person who will be going to the field using one rover, he will use that rover and it will get connected to the web. This position will directly go, his position wherever, suppose one building he want to survey, that building's position will directly go into the server, that position directly, and this is a GIS data. So that will transfer directly using CORS. So result viewed, where it is, data is logged simultaneously at CORS and rovers. Base corrections are transmitted via encrypt link to rover. Rover is initialized using data from base. Data is processed inside rover receiver's controller. Survey is conducted with processing within roving receivers continuing throughout. Result of processing are sent to controller for logging and viewing. Result viewed may be either lat, long, ellipsoidal height, or northing, easting elevations. What is CORS? CORS is a system that helps user find accurate position using satellites, wireless networks, and the internet. It works through a mobile client server setup, meaning user connect to a central system from this device. Who started it? CORS was established by Bill Strange, is known as father of CORS. So these are all theoretical. What is CORS used for? Real-time positioning for surveying and mapping, GNS survey for improved accuracy, Archive GNSS data for online post processing. Means archive means if you take this data, that is in static mode. We do survey using static mode. So we, in field we have observed for suppose 1 hour, then we come to the office, then we do post processing. So this can be also done. Suppose you have GPS and you are not registered with this one CORS stations. CORS station is not there. So you are not using CORS base. Your rover is not CORS base. So what you can do, whatever observation you have done, you come to your office, and if you give this data to the CORS server, it will automatically calculate and find it out, the coordinates. So this process also will show how it is done. That is practical part. This will be shown. How online you can find out the coordinates. How user can where it is? How can user access CORS? One is static method and another is network RTK methods. These all things I have mentioned in that one. Why we need CORS? GNSS is used for accurate location tracking. To get precise result, user needs correction data. This is done using static GNSS survey, real-time kinematic survey. Static GNSS survey and real-time kinematic survey. There are the two way of doing survey in GNSS. One is static survey, another is real time. And CORS, using CORS, we are doing RTK, real time kinematics. How does CORS do? CORS remove the needs for users to set up their own reference station. That one means another station is not needed. It is a permanent station we have created. So another station is not needed. How it works? CORS collects satellite signals continuously. Data is sent to center server. User can subscribe to the CORS network to receive corrections data from their servers. That's live means real time for instant use. Later for analysis and reporting. This is one diagram that I have mentioned there. Same thing it is mentioned in this diagram. You can see this is a control room, and these are CORS stations established. And this is a rover, that is unknown points we'll be finding out. This is, yeah.
It will take 10 minutes. Right?
Definitely.
It's online, you just tell.
So we'll be taking 10 minutes late to break. Okay. So we'll be coming here after 10 minutes.